Happy Monday, because today is Monday. This video is only a supplement to your notes. Please make sure you go over the notes, okay? Because I am going to cover only endothermic and exothermic reactions, plus 2 examples. But before we explain endothermic and exothermic reactions, I think we should make a few statements which will help us make sense of those reactions. So the first one I'm going to make is heat is not the same as temperature. Remember, heat or thermal energy is the energy transferred from one object to another due to a temperature difference. Now, temperature has to do with measurements and heat has to do with energy. They are connected, they are related to each other, but they are not the same. Okay? The next one is heat or thermal energy flows from hot to cold. That is, when two objects are in contact with each other, heat or thermal energy will flow from or will be transferred from the object with the higher temperature to the object with the lower temperature. Okay? Now, and there's a reason why energy is transferred. And that's because, according to the law of conservation of energy, energy cannot be created nor destroyed. It can only be transformed. Okay? So we cannot create energy. When we say create heat, what we mean is we convert or transform some type of energy into heat. Like when you go like this, we are creating heat, but really we're just transforming the kinetic energy, the movement of our hands into, due to friction, to heat energy. Because energy has to remain unchanged. And if we extend our definition from the law of conservation of energy to serve our purpose in thermochemistry, it would be during a chemical process, the energy of the universe remains unchanged. Okay? It sounds romantic when we say the universe, but that's the way it's done. And to better understand this concept, we have to divide the universe in 2 parts: the system and the surroundings. Now, my coffee mug, okay, a coffee cup. Let's say I had coffee in here, hot coffee. Our focus would be on the coffee because we want to see, how the temperature will change. So the coffee is the system, and everything else, including my coffee mug, is the surroundings. Okay? If my coffee releases energy in the form of heat, so that energy remains unchanged, then the surroundings will gain that heat released by my coffee. Okay? Because energy cannot be created nor destroyed, it'll remain unchanged. Hopefully that made sense. Now, let's go over the reactions: endothermic and exothermic. Okay? For an endothermic, the system gains heat and the surroundings loses heat. For an exothermic, the system releases heat and the surroundings gain that amount of heat. It has to be equal, okay? Whatever is lost by the system will be gained by the surroundings. Whatever gained by the system will be lost by the surroundings, okay? Let's represent a system with this house. And let me write system, the word system on it. System. And then we're going to represent heat and its direction with arrows using red color. Let's say we had heat energy going out from the system. You see the arrow. This is an exothermic. Well, let me also indicate outside the house, it's the surroundings. So okay. And if you think about it, exo is similar to our word exit. They both derive from Greek, right? From that's where you leave, that's going away, exiting. So if heat exits the system, it's an exothermic reaction. Okay, hopefully that sticks. And whatever energy and heat energy is being lost by the system will be gained by the surroundings in an exothermic reaction. Okay? Exo, exit, out, exothermic. Now, what if it was the opposite way? So let me draw an arrow as best as I can. Now you have energy going into the system. That's an endothermic. We do have a word which is somewhat similar to endothermic, and that would be entrance. So endo, entrance. When you go inside a place, business, shop, whatever, you go through the entrance, you go into the entrance. But the way I learned it is endo kind of sounds like into. So when you have energy going into the system, that's an endothermic reaction, okay? And remember, for endothermic, the surroundings will lose heat and it'll be gained by the system. For exothermic, the system will release heat and it'll be gained by the surroundings. It'll be better illustrated with these two examples. Example number 1. On a sunny winter day, the snow of a rooftop begins to melt. As the water from the melted snow drips from the roof, it freezes into icicles. Describe the direction of heat transfer as the water freezes. Is this process classified as endothermic or exothermic? These type of questions will always give you clues. And there are 3 main steps to solve or work on this example. The first one is determine the system and the surroundings. Where is our attention focused on? If you look at the question, describe the direction of heat transfer as the water freezes. So the water is the system because we're going to focus on what happens to the water. So let's write system would be water. And then everything else will be the surroundings. We'll say air. So surrounding air. Now let's determine the direction of heat transfer, the flow of heat. Let's use red. Notice that the water is being frozen. So of course, if something freezes, it's going to get colder. For something to get colder, it has to release heat. It has to go down in temperature. So the water is releasing heat, and that's why it gets frozen. So it's flowing from water to air. Whatever gets colder is releasing heat. The water is getting colder because it's being frozen, so it's releasing heat. From water to air, from system to surroundings. So let's draw an arrow from system to surroundings. If we look at our table, from system to surroundings, that's an exothermic. So the system, which would be the water, is releasing heat, and the surroundings, which is air, is gaining that amount of heat, okay? So it's an exothermic. Very good. Example 2. When barium hydroxide octahydrate, there's the formula, is mixed with, sorry if I mispronounced this, ammonium thiocyanate. And there's the formula. A reaction occurs. The beaker becomes very cold. Is the reaction endothermic or exothermic? Where's the clue? The beaker becomes very cold. So beaker would be either the system or the surroundings. However, notice we have the chemicals, and we're going to focus on the chemicals because they're reacting, okay? So the system, oh, let me redo that. System, chemicals, surrounding, would be the beaker. Next step, direction of heat transfer, the flow of energy or flow of heat. What's getting colder? The beaker, meaning it's releasing heat. So it's going from beaker to chemicals. Let's draw an arrow from beaker to chemicals, so from surroundings to the system. We have heat energy going into the system, so that's an endothermic reaction. For these kind of problems, make sure you follow the 3 steps one by one, and it'll make sense. Don't forget the arrows. Those help you a lot, okay? That's it, guys. Fly, Eagles, fly.